Repeat.
Can you come again?
Can you repeat what you asked?
Which chapter you have prepared after this alcohol, phenols, ether?
I've prepared almost all because we have exams coming.
Which chapter?
I have prepared almost all because we have exams.
You didn't prepare any chapter. Right? Okay, 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 okay. So we are going to see about the electrochemistry. Okay. That's good. Let me see once. So in electrochemistry, this first question is based upon Squad-Lott's law. You can do this easily. And the next is you can go for the mobility in aqueous solid. Lowest. Priya, will you be able to do this? If you are not able to do this, just let me know. Very good, Aisha. Priya, let me know if you are having any issue with this. Very good, Aisha. Go for the next. Priya, are you able to solve this?
Sir, I'm trying.
Okay.
Which question, sir?
Question number one from one. Very good, Aisha. So here you need to calculate the lambda naught m for CH3COOH. So basically, how you are going to do it is lambda naught m for CH3. Just wait. For CH3C double OH will be equal to, we can write according to Corlow's law, CH3C double O negative plus lambda naught m of H positive. And from this, you are going to break this into ions in the same way that we did for this. And it will be lambda naught m for H plus. And when you are going to dissociate this, 2 H plus is there. So you are going to multiply this with 2 plus lambda naught m for only one SO4 minus is there. 1 SO4 minus 2 is there. In the same way, the next 2 into lambda naught m for K plus lambda naught m of SO4 minus 2. In the same way, you are going to dissociate this. So you'll be getting lambda naught m for CH3, C double O negative plus lambda naught m for K plus. So what do you need from this? So you need CH3 C double O minus, which means basically that will come from the third equation. This is your third equation. And you need H plus, and only one H plus you needed. So from this. So what we are going to do, equation 1, let's say this is your equation 1, this is your equation 2, and this is your equation 3. You are going to divide equation 1 by 2 and add into the third equation. Add into the third equation. And you add into the third equation, and also you can see you don't need K plus. There is 2K plus in the second equation, and there is only 1K plus. So you are going to multiply this by 2 and minus second equation. When you will get when you will do it, you will be able to get Z x y will be as it is. You divided the first equation x by 2, and then just wait a minute, did a mistake. First equation is your x, which you divided by 2, and you added in the third equation by multiplied by 2. So 2 into z minus second equation. So second equation will be as it is. When you are going to solve it, you will be able to get second, just wait a minute. Y is K2SO4. 2K. Oh, it's better to multiply here than divide this in the second equation. So y by 2 will be there, and you just need to solve it. That will be as it is. So you will be getting the answer A easily. You just need to play with the equation and you will get it. Have you solved this type of question, Fia?
Yes, sir.
Okay. The next you can see ionic mobility of which of the following alkali metal ions in aqueous solution. Lowest you need to see. So see, if the Li plus, Na plus, K plus, and Rb plus we have, when you are going to dip this in aqueous solution, due to hydration energy, the maximum hydration energy of this lithium, smallest ion will be greatest one. The basically hydration enthalpy is inversely proportional to size of atom or size of cation. So since this will have the most hydration energy, that means it will be surrounded by the most water molecules and it becomes heavy and the largest one. In aqueous solution, Li plus aqueous will be the largest one, followed by Na plus aqueous, followed by K plus aqueous, followed by Rb plus aqueous. This is the size order, and since its size increases, the ionic mobility decreases. So lithium. In the next one, you can see aqueous solution of which of the following compound is the best conductor of electric current. That will be HCl, because all of other are non-electrolyte. Non-electrolyte, that means it will not dissociate into ion. If it is going to dissociate, like acetic acid, it will be very less. Weak electrolyte it is. Okay. But this HCl is a strong acid and it will be 100% dissociated. So the number of ions will be greater and hence it will be the best conductor of electricity. The fourth question, it's simple. Alpha, we need to calculate alpha. Alpha is equal to lambda m upon lambda infinity m. Molarity at dilution, infinite dilution. So it will be 9.54 divided by 238. When you are going to divide it, you will be getting 0.048 something, 0.04008 something. And so this is the value of alpha, but we need in percentage. So you are going to multiply it by 100 and you will be getting this. The fifth is also very simple. It's on the basis of Coriolis law. You need NH4OH. So you are going to find out NH4OH. You need NH and OH. The rest should be cancelled. NH4 is there, chlorine is there, Na is there, Cl is there, Na is there, OH is there, which is in negative. So it doesn't make any sense with NH4Cl. And Cl is also not getting cancelled because it is in positive. But when you are looking at B, NH4 positive is there, Cl minus is there, Na plus is there, OH minus is there, Na plus is there. But this is in negative and Cl minus is there. You can see negative Na plus and positive Na plus will be cancelled. You can see negative Cl minus and positive Cl minus will be cancelled. Only left, you will be left with NH4OH and OH. So this becomes NH4OH. Is that clear, Priya?
Yes, sir.
Okay, moving to the next question. This is NCERT question which has been asked in NEET. The sixth question. Very easy. Any answer? Six is correct answer. That is your told it's D. Seven is incorrect answer. I'll explain it right now. Just wait a minute. Sorry. Very simple it is. If you're going to see an increase in equivalent conductance of a strong electrolyte with dilution is mainly to 100% ionization of electrolyte at normal dilution. That will happen whether you are going to increase the temperature or not, or dilution. 100% dilution already occurred. Increase in both number of ions. Number of ions does not increase. Why it is so? Because it already dissociated 100%. So how can the number of ions can be increased? Increase of number of ions cannot happen. Only increase in ionic mobility of ions occurs because of this dilution. So that's why. In question number 8, C is the correct answer. Is question number 9, D is the correct answer. Very good. Going for the next. Fia, Fia, are you there? What about you?
Yes, sir.
Have you got all of it or not?
Yes, sir.
If you haven't, just let me know. I'll explain one by one. Just give me a minute. I'll show you this. Just try this before ending of class. I'll explain each one of them. You haven't revised this electrochemistry here.
Yes, sir.
Okay. This topic is for next class. Here, if you are not able to do, just let me know. Are you able to see the screen now? Aisha, are you able to see the screen? As Pia is not able to see the screen. Is it blank for everybody's? Can you see? Aisha, are you able to see the screen? Yes, Aisha is able to see the screen. I think Pia, you are not able to do due to network issue. Tenth is incorrect, Aisha, and 11 is also incorrect. See, if you are going for 10th, Corlot's law states that finite dilution each ion makes definite contribution to equivalent conductance of an electrolyte, whatever be the nature of the other ion of electrolyte. This is wrong statement. What does this Corlot's law states? It states that it in finite dilution, each ion migrates, right, independently. So according to that statement, if you are going to see, D is the correct answer. In finite dilution, each ion makes definite contribution to equivalent conductance of an electrolyte, whatever be the nature of ion of the electrolyte, whether it is strong or weak. So if you have a cation or any electrolyte, whether it is strong or it is weak, this will be the scenario. So D is the answer. For 11, what you had given is A. That is incorrect. You have to be careful while solving the question. The ionic conductance of Ba plus 2 and Cl minus is 127 and 76 ohm per ohm centimeter square at infinite dilution. The equivalent, you need to calculate equivalent conductance of BaCl2. Okay. So BaCl2, so for BaCl2, you know that it will be equal to lambda naught m of Ba plus 2 plus lambda naught m for Cl minus. But if you are going to look at this carefully, this is your equivalent conductance we need, and this is how we are going to do it. This I have written for M. You need to do it for equivalent. And in equivalent conductance, we don't need to balance. We don't need to balance like here. It is Cl2. If it is molar conductivity, you need to multiply it by 2. So what you need to do is very simple. 127 Ba plus 2 is 127 plus 76, right? So when you are going to add it, you will be getting 203. So the answer will be B. I think you multiplied this twice, right, Aisha? So for equivalent, it will be as it is. If they have asked molar equivalent, molar conductance, then you are going to write like this: lambda naught m Ba plus 2 plus lambda naught m Cl minus, and since to balance it, you need to multiply it by 2. Got it, Aisha? 12B, 13C. Very good. The rest is correct. 12 and 13. 12B, 13C. Fia, are you able to see the screen now?
No, sir. Is it possible to send a screenshot of this in Zoom chat only?
It will be very difficult. Let me see whether I don't know. I think your network is weak. I will be
But I can hear whatever you say properly.
see, but question should be there now. Like you should know the question. Which question is that? Okay. I will send the PDF photos of this question. Okay. To the admin, and he will coordinate with you. Any answer? Any answer? Oh, 14 is not B. 14 is your D. And 15 is correct. C. So see how we are going to calculate it. First, you are going to calculate a specific conductivity kappa that will be equal to cell constant, that is G star upon resistance. So you can see 0.4 is given upon 40. That comes out to be 0.01 per ohm per centimeter. This is your specific conductivity. After this molar conductance, you need to calculate that is equal to very simple 1000 kappa. You can apply this 1000 kappa into upon molarity. This is the scenario. When you are going to put the value 1000 into, I can write 10 raised to the power minus 2 upon molarity. What is the molarity? That is 10 raised to the power minus 2, right? Okay. So as you can see, when you are going to solve this, this will be cancelled and you will be getting 10 raised to the power 3. Isn't it, Aisha? This you can do easily. 17 is very simple. Diamond is an insulator. Oh, 16 is Faraday's law. You can directly apply the formula of Faraday's law. W is equal to equivalent weight into I into T upon 96,500. You need to put the value 108 is the equivalent weight of silver because n factor is 1. I current is given as 0. 0.5 and time 100 minutes into 60 seconds. So it becomes out to be 6,000 seconds divided by 96,500. You'll be getting 3.375 grams. So the correct answer is B. You have studied M is equal to M directly proportional to Q and Z into Q. M is equal to Z will be equal to Q will be equal to I into T. M is equal to E by F into I into T. E is equivalent weight, mass, equivalent weight of silver is 108 because it lost one electron. So n factor is 1. Isn't it easy? Okay, so this is it for today. Thank you so much. In the next class, I wrote the topic. Only from this topic, I'll be asking questions, nurse question and ECS. Okay. I feel like yes. Thank you.